giving me this great opportunity to talk to the Power Platform crowd. It's actually, I'm trying to keep it worthwhile to whomever is attending today, and I really appreciate the time you guys are giving, especially it's a Saturday, it's a weekend, you should be doing more interesting stuff than watching me, but I will try to make it worthwhile. So just full disclosure, I'm in a ocean of wires now, so if anything goes boom, don't panic. Let me start. I'm gonna spare you the PowerPoint really, because this is after all a developer bootcamp. So I don't think PowerPoint would be suitable here. So I'll just jump directly into the topic and the code really. So since Microsoft have recently released Power Platform, as you can see on my shared screen here, source code, now everybody can have a look, maybe tweak it a bit, and so on. And one other repo I found very helpful was Microsoft PowerFX host samples, which have lots of interesting stuff that you can play with. And what I have been doing really is, since PowerFX have been always self-contained with Power Platform, so now we can, since we have the source code, we can port it to different platforms, maybe run it on Linux, maybe run it on some IoT devices. I have this interesting gadget today with me, Raspberry Pi, if anybody can recognize it. And basically speaking, since it's run on .NET Core, so you can use it on .NET Core 6, for example, and run it on ARM processors, such as in the case of Raspberry Pi, and so other many ubiquitous devices, really. And today I will be running it on Raspberry Pi. So as you can see on my screen, Raspberry Pi is really credit-sized, credit card-sized computer. It's basically a computer on a board. So you have lots of interesting stuff here. Starting with 2 HDMI ports, which means you can use dual display as if it is a developer machine. You have gigabit Ethernet, you have USB 3, USB 2, you have obviously the microprocessor, which is ARM. It have, if I recall correctly, 4 cores by now. You can actually go ahead and read the details here. So it runs on Broadcom BCM 2711. It's a quad-core Cortex A72. It's ARM v8, which is supported by .NET 6, .NET Core 6, and it's a 64-bit SoC. And speaking of which, previously it used to run on Raspbian Linux, which was a 32-bit distro. And recently, Raspberry Pi did launch their Raspberry Pi OS, which is 64-bit, which I'm using today. It have been quite painful to try to use, like, let's say, some of the Python libraries for Azure stuff, like pipeline, like service buses, etc., because some of them are only supported in 64-bit. So, which means we used to change the distro to something else, like Ubuntu or something like this. But now we can use it directly on Raspberry Pi out of the box. To image a Raspberry Pi, there is also a new tool called RP Imager, which can make it very quick. You can do it from Windows or Linux, doesn't matter. And you can use what's called Raspberry Pi OS Lite, which I'm using today, which is a headless installation. So I don't have a desktop here for Raspberry. I'm just connecting over SSH like so. So I have 2 Raspberries today. One which is Raspberry Pi 4, the latest and greatest, and the other one which is a little bit older, which is this one. So this one is an older version of Raspberry Pi. Okay, this one is running on Raspbian, as evidenced here. So you see, this is running Raspbian Linux. Okay. And the newer one is running on Raspbian OS. Okay. Sorry, this is all. The newer one is running on. You see. So this is Bullseye Debian, which is the new release of Raspberry Pi OS. Okay. So let's have a look at the source code of the samples, which I just mentioned. It's very handy. So I have this version. I'm basically using the console REPL, the REPL console, which basically means when you run it, you can interact directly with PowerFX like so. So for instance, now it would give us today, help will give us available functions. And if you look closer here, you'll see that if you are familiar with PowerFX already, you can see that I have some extra functions here, like send message or where is Santa, that was suitable for Christmas, or lead matrix print or read temp. And basically what I'm doing here is I'm reading data from this nifty device. It's called SenseHat. And SenseHat is actually an intriguing device, really. It's part of what's known as AstroPi. So it was developed initially to enable you to build microsatellites. So it have lots of sensors on it, like a gyroscope, accelerometer, temperature, pressure. So you can use it for many projects, like you can do your own like weather station or something like so. I'm getting a message saying, please share your screen. You guys can see my screen?
We can see your screen, Fadi.
Okay, so everybody is okay. Yeah. Cool. So I was saying this SenseHat you can see here, it comes with lots of sensors and so on. And there's a few libraries out there running on .NET, which enables me to incorporate it within PowerFX, build some functions that I can use. So let's read through the source code here to understand how it is structured. I'm going to just stop this. And let's go for a simple function. Like, let's say, I'm going to go here. Like the one that comes with like exit function or help function. So let's go look at something simple like reset function. Okay. So if you look here, you see it's quite straightforward really to extend PowerFX and add extra functions. So what you need to do is to inherit from this class called a reflection function. Okay. Give your function a name like so. Basically, you will be inheriting the constructor. So the constructor obviously have to have the same name, reset function. And then you are inheriting the constructor from reflection function. And basically, you give it a name here, and then you define what should be the return or any parameters. Let's have a closer look. If anybody having an issue, please just give me heads up, okay, to see my screen. So I'm gonna have a look here as a definition, and as you can see, the constructor here have a string, a name for the function, the return type, which is of formula type, and there are parameters, which basically how many the parameters you are going to pass into your function. Okay. So let's have a look at the formula type, and you see here that the types available for us are like blank, Boolean, number, string, time, date time, etc. Okay. And today I'm going to keep it simple, so I'm going to just use basic stuff like Boolean, number, string. Okay. So I'm going to one of my classes here, like let's say the lead matrix print function. Okay. So here I'm inheriting from reflection function. Okay. I'm inheriting the constructor like so. I'm giving it the name lead matrix print, and the formula type here is Boolean. Okay, that is a return. Just tell me it was successful, and I'm passing in a message, so it have only a single parameter. Okay, and basically I'm using this sense library. So if I go there, go to the definition. Sorry. Yeah. So it's part of this library called Sense, and you can see I've been using it here. Yeah, SenseHat. It have a nugget, so it's quite handy to use. To be honest, there is another library that was recently released by Microsoft. It's called, if I recall correctly, devices.bindings. system.devices.binding or device.bindings, but I hadn't have the time to review it because I tried to use it with another demo I have today, which had PWM same full screen is not available. I'm still. Can everybody see my screen? Can you confirm?
We can see your screen. Yes, correct.
Because some people here are keep saying that maybe I will just turn off notification or something here, so I wouldn't be distracted. So you have since had net here. Okay. And here is the GitHub for it. Okay. And it have.
Hi, Fadi. Just to let you know, so what we can actually see is actually your actual personal image. So we can see your screen. It's just because it's what we can't see is like a full screen experience, but that's fine because it's good enough. We're not getting the full quality, but it's good enough, it seems.
Okay.
But yeah.
So you can see this GitHub repo, for instance, and you can see my video feed on the corner here, which I'm moving now. You can see that?
Yes, we can. Yes, we can. But for some reason, it's a square. It's not a full rectangle. But that might be to do with your configuration. But it's fine. It's good enough, I guess. But it's not the full experience. But yeah, just to let you know.
Okay. You like me to switch to desktop?
Well, I'm gonna try one thing. I'm gonna try and spotlight you and see if that helps.
Okay.
So I'm gonna spotlight you now. Hi. I think that's helped. I think that's done the job. So we've spotlighted you now, and that's definitely made a huge difference.
Okay.
So can everyone?
Okay, yeah, because we will need this OBS virtual camera because I have lots of demos that require a video stream. So let's continue. Okay, great. So I have this nugget since .NET, which I'm using as part of my project here. And going back, if you notice, I'm using the PowerFX core and interpreter, which comes from the previous GitHub for PowerFX I just shown you. I'm also using Azure messaging for service bus. I'm going to use this later. Okay. And let's go back here to the code. So basically, if you want to create a new function, let's say a hello world function, you can basically, I mean, like I'm going to use this like a boilerplate code. Okay. And just paste it here. Okay. I'm going to obviously change the name to something else. Let's call it hello. And the constructor should be the same name, hello. And I'm going to change the function name, so hello as well. And basically, I'm going to just we have in the execute function here. So I just need to add a parameter. Or actually, no, let's keep it simple. So hello world. Okay. And if I run this, oh, sorry. I need a return because I did say there's a return. So let's have a return here. And as you can see, the return is true. So it's a formula type of value true, Boolean. And if I type help function here again, I should be able to see a hello function. I need to change my glasses soon. Well, let's just execute it. Oh, it's not supported. Maybe I did not. Invocation of a non-support. Not sure if I did build this. It's build. Oh yeah, I forgot something important, guys. I keep forgetting this every time. After you define a new function, you need to add it to the engine like so. So here is the line for it. Okay, so don't forget like me. And basically you need to pass a new instance of your new class, which is hello. Okay. I'm gonna type help to see that it's now listed. So it should be here. Hello, 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 hello. Yeah, see there? See it? And let's test it here. Hello. So it says hello world and returned true. Okay. So that's our hello world extra function extension for PowerFX. Let's look at something more interesting. So since this can compile in .NET Core, then like I mentioned earlier, we can run it on this Raspberry Pi here I have. Okay. And I'm gonna be talking to the Sense hat. Okay. So this means I will need to connect to the Raspberry Pi, which is this one. So I have the project here. No, this is the different one. This is a newer one. I have the project here under Bootcamp. Okay, it's called, basically I cloned my own forked repo from GitHub here, which by the way has the source code. I'm gonna share it with you later. I'm gonna PowerFX samples. Oops. Perfect. Unless, okay, here's my project. Let it run. Okay, so now we have the console here. So let's check the available functions. Help. Okay. So you see, I have lead matrix print. This is the one we are looking at here. So this is the one. This is source code for it. And what it does basically, it says, I'm inheriting from the base constructor again. I'm going to return a Boolean flag. I'm going to accept a string parameter. My name is lead matrix print. And I basically, on execution, I'm going to get the message value. And what I'm going to do is using the nugget I shown you earlier, I'm going to use sense hat to show this message value. Simple, straightforward, okay? So let's call it by name. Lead matrix print. So Freddy says hi. So I'm going just to hold this here since the other camera is pointing at something different today. Okay. Yeah. So ready? 1, 2, 3. Yeah. Freddy says hi. Okay. So let's try other stuff like maybe read temperature, for example. Read temp. Okay. So you see that current temperature now in the room is 22.15. So it's quite warm in Dublin today. And we have here read pressure. Let's try this one, see if it does work. A bit read. Just get the correct spelling. Kind of regretted using long names now. Pressure, yeah. Yeah, apparently I did not deploy the latest version of this. So this is only on my machine. The Raspberry Pi does not have it. No problem. I have some other like Easter eggs, but for Christmas. So like, where is Santa? Basically, I'm talking to an API here, and I'm just getting the location and printing it out on a, so you can hang this in Christmas on your Christmas tree or something. Okay, and the other function of interest is send message. Okay, so basically this talks to Azure Service Bus. Okay, and what I'm doing here today is basically I'm going to send messages from PowerFX to Service Bus, and I have a drone here, which I have to switch now. Okay, you see that drone is a picture down there in the corner. I have a drone here which will basically have a Python script. It will read the service bus, and based on whatever message is going to execute it. So let's have a look first at the source code for this Python script. Okay, so this is an actual live connection, so don't hack me yet, guys. I'll let you play with it later, but let me just walk you through it. So now we are importing rpi.gpio. That is, if you recall from this picture, you see this part, the pins over there. This is really very handy because it have lots of features, like it can communicate over serial protocols, I2C, PWM, and PWM basically stands for pulse width modulation, and it's a square signal really. And based on the duty of that square signal, you can talk to a servo and tell it how much power you would like to run on, which I'm going to use today to tell the truth on how much power I would like to have on each channel, like throttle, for instance. Okay. And here in this is, so if you wish to know what are the pin numbers and so on, you can just type pin out like so. So you can see here on my screen, I have 40 pins on the GPIO. GPIO stands for General Purpose Input Output. Okay, so it's 40 pins on like, I'm not sure if you can still see my image. You see, I'm having this cable connector here. Okay, so this is the header for it. Okay, and I have like 2 5 voltage power supply, which means you can power up your circuits from it. I have a ground. There's two numbering schemes really. One is the board number, as in how the pin is numbered on the GPIO on the board itself, and one is chip number, which is which chip pin on the Broadcom processor. So here I have GPIO 14 is 8, GPIO 15 is 10, and as you can see, it goes on. And if you are more interested, you can go to pin, like if I'm gonna just Google it for now or Bing it. There's a website called XYZ actually. Yeah, this one. So you see, I have an interactive way here to tell me what every pin does. So for instance, today in my script here, let me show you. I'm gonna have this. I have it already. Yeah. So here I'm talking to PWM channel on pin 35 and 12. Okay. And I'm using the GPIO out And basically, this is, I'm using the board numbering. So going back here, GPIO 12, 18, 12, I mean. So that's a pin number on the board, 12, so it's GPIO 18. And 35, which again, GPIO 19. And here you can see some details about it, okay? Not gonna delve into the details, but here's a legend here that basically tells you PCM, which is pulse code modulation, which would generate the PWM, pulse width modulation, okay? If you are into embedded systems, these are maybe already obvious to you, but if you are not from this area, maybe you might find it a little bit tricky. So let me reiterate, you have two numbering schemes. One is board numbering, and one is a GPIO actual numbering with ship numbering. And today in my script here, which I'm going to provide you later on GitHub, I'm using the GPIO board, okay? And basically I'm doing a setup. So I'm saying that 12 and 35 are going to be out because you can control if the pin is in or out as in terms of signal, okay? And here I have the connection string for our service bus. And the queue name is gonna be messages. And basically I'm saying the rudder, RUD, because you see in a drone you have like different channels to control different things, like rudder as in how it would go in like yaw, if I recall correctly, pitch, and let me just show you this rather than trying to. Unroll. Yeah, so a drone like an aircraft, really. Let's use this one. Okay. So the rudder would control the yaw axis, as in like how it go in circle like so. The roll is like how it will go, like lean to the right or left. The pitch axis is if the airplane is like taking off or landing. In the case of the drone, it's like going forward or backward. Okay. And I'm using this in my code to basically set the rudder and the throttle. Okay. And I have here, I'm going to basically start the PWM at 10, because you see, in order to talk to the flight controller from on the drone, which let me just switch places now to show you. I have to move around. Okay. So I'm gonna just make this a little bit bigger and bring it to the front. So here's a quick crash course on flying drones. So here, this is the flight controller, okay? And I have a Raspberry Pi here talking to it. So here are the channels, which would be talking to the PWM channels on the pin out, okay? So a drone will basically have a flight controller talking over these cables to what's known as ESC, these units there. And ESC stands for Electronic Speed Controller. And basically it will be controlling the rotors. For safety reasons, I'm having these off. I just have this to show you because I don't have sound here. So just gonna show you that it does spin, okay? And it's not connected, it's just there. If in order to install it, you'll need to actually use this to install it, but it's just there just to show you that it does spin when I tell it to do so, okay? So the mechanism will be like following. The service bus Python script will be talking to Azure Service Bus, okay? Getting the messages, once it gets a message, it's going to talk to the flight controller, arm it, then spin the rotors here without the propellers, and then it would fly if you wanted to. Obviously, we don't have the propellers today, so no actual flying is going to take place, because you see these rotors can be very dangerous because you can injure people easily. And this overall, it's like with the battery here is like 2 kilograms, so not a good idea to fly it in an office. Okay. Going back to coding. And basically, I'm keeping it very simple. I'm having a function called FC as in flight controller. The flight controller will basically get a message from the service bus here. So let's say I have received a message like so. I'm going to talk to the Python function, tell it the message, what is the message, and then tell the service bus that message was completed, which basically takes it off the queue. Okay. And here I have arm, which would arm the drone, because like I told you, these drones, since they are do-it-yourself, they are heavy duty, which enable us to customize them, but they are very, you need to make sure that when you arm the drone, they are like 5 meters away for safety. So safety is a very big concern here. And this would arm the drone if I wanted to. This would disarm it by basically stopping the throttle and clean up the GPIO. This will spin by changing the duty cycle I was telling you about, which would change the PWM to 15, okay? This would fly it, which change the duty cycle to 20. So as you can see, there's very little difference between 50 and 20 because this is PWM. This is not like linear. It depends on the frequency which we are using. And the frequency is 100. So we are using 100 for both PWM channels. So here, as the rudder and the throttle are talking to the drone over channel 4 and 3 on the flight controller. So enough of drone mechanics. Let's look at the service bus. So the service bus is quite straightforward. It's a service here on Azure. So I have one here called PowerFX Service Bus. And here is a Service Bus Explorer, which allows you to peek into the messages. So let's do first a dry run by using PowerFX. So okay. So for sake of time, I'm gonna just send commands like so. And if I do so, like you see, it says, okay, the command was sent. It's sending over this connection string to queue named messages, and the messages spin. So if I go back to my Service Bus Explorer and peek, so I can see the messages. Actually, for safety, I'm going to do a receive instead, so I don't get random messages during the demo. Message sequence number is 42. How convenient. And as you can see, the message is spin. So if the Python script is running on the drone on the Raspberry Pi, obviously it's going to take the spin message and execute this function, which would basically change the duty cycle to 15 and tell you that throttle now is on 15 and spinning. Okay. So one thing to pay attention to is this Python script. Once you execute it, it's going to arm the drone. So I'm just having a sleep timer here for 7 seconds, which hopefully will allow me some time to go around the room, arm the drone by connecting the battery. It's a LiPo battery, lithium polymer. And this is because you see, as a safety mechanism, the receiver should be always enabled and powered before you actually power the drone. So I need to power Raspberry Pi first. and basically, sends the PWM first, the PWM signal to tell the drones that the receiver is there, so it wouldn't give you an error. Okay. In the real life scenario, obviously, you will be running Raspberry Pi on a battery rather than connecting to a charger like so I have here. Okay. But I'm doing this for demo sake because you see LiPo batteries are very sensitive, and I don't wish to run something as heavy as Raspberry Pi on this LiPo battery during a demo. So this is a safer way to do it. Okay. So let's try to run the drone. Are you guys excited? Let me switch the scene to drone. Okay. I'm gonna just minimize the screen a bit. I have this screen, which is for our Raspberry Pi 4, which we don't need now. So we have the script here, just to confirm ID drone. That's the same code you have seen with a service bus connection. Okay. So license free, ID drone. Okay. I'm just gonna switch on stuff now. The camera does not have audio, so you won't be hearing it. So you have to see this propeller just moving to figure out that it's actually moving. But I have another video recorded for this in case this doesn't work, so I'm gonna share it with you. So let's run our project here. Okay. Oh, it's already there. And let's make sure that you can see it. Yeah. And here, this is, I guess. I think this is the wrong screen. Just to make sure that you guys can see everything. So here's drone, RFX, window capture. I'm gonna use, yeah, that is the correct one. Ah, okay, the drone picture is hiding it. Okay, so now we are ready. I'll just put the command there. You see the flight controller with this arm automatically, in case it did not receive any signal at all. Again, another safety feature. Okay, so I have the drone feed ready, the application here, the PowerFX console ready, and the Python script ready. So I'm gonna try to run it now. And 1, 2, 3, go. And then I'll just go arm the drone. So if you did hear a beep, that means that the drone is now armed. You have to read it upside down. So now there is a message there saying armed. Okay. And let's send the message from PowerFX. Spin. So now the drone is spinning. I'm not sure if you guys can hear this. Let me move the noise suppression from Teams. And I guess you can see the propeller moving. Yeah.
Yes, we can.
Yeah. So let me just turn off sound noise suppression. Device.
We can hear the propellers too, yes.
Oh, you can? Okay.
Yes,
Good.
yes.
Good. Today. So let's say I'm going to send the next message, which is fly. So basically now the throttle is on maximum, take cover, because if this is actually real, like actually flying, it can be quite dangerous. Okay. And now the drone is flying and everything is doing great. Done with it. So let's send a disarm message, which is going to disconnect it. So if you do not hear the noise anymore, that is because I just disarmed the drone and the rotor stopped as well. Okay. So as you can see, what I have done so far is I'm using PowerFX way beyond its original intention. I'm using it for robotics and IoT applications, really. And the idea is, since you see drone manufacturers have very high prices for their products. So for instance, I'm using a very cheap flight controller there. It's like 20 euros or something. But if I wanted to have something with the same capabilities, like having something as a Raspberry Pi computer on it, it would be very expensive. I mean, like you would start with pricing around 200 and way up. And if this is not a do-it-yourself drone, then you're talking like thousands now. So the idea is, since drone programming is very convoluted, it doesn't have much of a community around it. Most of the source code is not really maintained. Maybe it's better to use low code. And obviously, the application I have today is a drone, but you can do it for any robotic thing, like a robotic application, maybe like a little car, or even a factory equipment or whatever. And I'm doing it using low code. So here in PowerFX, obviously I can have a different interface, like maybe a web application or a Windows application, or maybe have it as an API where I send messages as in PowerFX low code, or even integrated with Power Platform, obviously. So rather than having PowerFX talking directly, you can maybe, in the future, I have been talking to Microsoft guys, and they say that on their roadmap, there are plans to upload your custom PowerFX. So if you go and extend your PowerFX with helper functions like I just did, then you can upload it to Power Platform and use it from there. And then you can add all kinds of interesting stuff, like talking to devices like these, or maybe something else that is custom, maybe a drone, maybe a full-blown robot, or you can imagine the potential here, and it's all low code, so it kind of democratizes the field. So you no longer need to write it in embedded C, as in like C++, like C, or like Arduino, or I mean, like, or even Python. Python for some people might be a little bit difficult. So maybe we can enable those people to use it or do these kind of applications using low code, which opens a whole new field there. Like imagine automating a factory equipment using low code rather than having someone to write the gluing code between your business application and the factory equipment, something like so. And so today I covered the fact that Microsoft did release PowerFX source code and the samples, what is a Raspberry Pi, and how we used service buses from Azure to talk to it, and how we actually executed the PowerFX directly on the Raspberry Pi itself. So if you notice, there are two types of demos today. One that is executing PowerFX directly on hardware, like in this device when I was talking to the Sense Hat, okay? And another where I'm talking to a drone, but I'm not executing PowerFX directly on the drone. I'm executing it somewhere else, but I have extension functions that can talk to something like service bus, send messages over it, and talk to a drone or whatever, and basically talk to, like in our case here, the flight controller over PWM via Python. And maybe in the future, actually, there is a new nugget from Microsoft to talk to PWM supported devices directly. I'm still testing it, so maybe in the future we won't even need Python in place. It's going to be all full low code. And by that, I conclude my session. I really thank you all for being there, watching this. Hopefully you enjoyed it. Hopefully you learned something new. And I'm open for questions now.
Wow, thank you, Fadi. As far you actually exceeded my expectations there with what you're going to do with Power Effects. You really have. So thank you so much for sharing that. It must have taken a long time, you know, to actually build out this proof of concept. So let's take a look at the questions in here.
Sure.
So a lot of people were quite interested actually in what you're up to here. Are there any questions in relation to Fadi's session? And don't be shy, even if it's a very basic question, you know, because to be honest, Fadi, a lot of the people that have joined us today are new to Power Apps development. And I think the first question by Shefali is, do you have a Twitter handle to follow?
Yeah, it's at Fadi Anwar, my name. Let me type it there. And you can there's another guy with my name. So I'm gonna just keep a space between at and Fadi Anwar, okay? You remove it. Add the at then. Also, there's a website with more details on these projects. So fadianwar.com. You might want to have a look there. There you'll find a link to the GitHub with the source code I used today, with all of the functions, including send messages. Actually, if you still have time, you can clone the source code and actually send messages to the drone right now. I will be arming it for you. Any further questions? Don't be shy.
Thank you, Fadi. So obviously you've got a setup here. You're running as your service bus. So could you share a bit about your development setup? Like, how did you get started? A lot of our developers are new to Power Apps development. So in terms of getting your development set up, what were the steps?
Okay, so let me go to my website here, if you don't mind. I have so today's session, including the sense hat, is can you find it in this article? And here is the steps I just shown today to add new functions, including this step, which I keep forgetting about. You can clone my GitHub repo from there with the example functions, okay? And this is how you run it, how you test it. Is a quick demo on YouTube, okay? Some examples of read temperature, read pressure, the lead matrix sprint, read temp. Some further, you know, playing around with Power FX functions like the round function here, for instance. Here I'm showing how to actually script Power FX. So not just using the console application example from the sample, I'm actually doing it as a scripted, what is the word, like scripted shell scripting. And there is a previous article there which details the configuration, how you set up your Linux machine or Raspberry Pi to basically have Power FX enabled as a shell scripting. So here you would publish, okay, you get a binary, you use it as a user binary. I have some questions here. You copy it under your binary, and then after you add it as a pass variable here in your shell, voila, now you can actually execute shell scripts running PowerFX rather than Bash or Python or something else. And here I'm having a hello world, and here is a script so that you can execute directly. So this is something that maybe would interest the guys here. This is how would you set a development environment. I'm using, I have been using Linux fully to make sure that it's going to always work in open source, okay? And that would be the acid test of open source. If it doesn't run on Linux for any reason, or a different platform like a different microprocessor, then maybe it's not fully open source yet. So that would be the acid test of being open source or not. I can see some questions there. What came to your mind when you started building this robotic stuff from PowerFX? I mean, it's a very unique thing I have seen using. Oh, thank you. Well, I mean, like, to be honest, he was trying to you see, to stretch my abilities really. So I was exploring different fields. So for instance, one field was robotics. So I was developing embedded systems, IoT devices, and so on, purely outside of .NET. So I was like using Android, C, obviously, Python, and so on. Then I thought, hey, what happens if we actually try to integrate this with Power Platform? So I started doing so using Azure Service Bus, but Python on the hardware side. Okay. And then I figured actually we can, since PowerFX was open source, then now we can actually use it, customize it, and deploy it to ARM-based platforms on running Linux like Ubuntu or Raspbian or Raspberry Pi OS, and do interesting stuff from there. Okay. And that would be, I mean, like, where I got there. I mean, like, obviously in my day-to-day work, I work a lot with Power Platform as a solutions architect. And I was intrigued to how far can I push the limits? How far can I take Power Platform and PowerFX? And here we are. We can do interesting stuff, really, I guess. Okay. Any further questions?
Any other questions for Fadi while we've got him online? Lots of people are really interested and you know, amazed and, you know, excited on what you, on the art of the possible here. Where do you see, Fadi, where do you see PowerFX going in the next, say, 1 to 2 years?
Well, since it's open source, the skies are the limit. I mean, like, think about it. I mean, like, most programming languages that became open source kind of exploded, like is the case for Python, for instance. So since Python is an easy to adopt programming language, everybody is using Python in schools and so on. So since PowerFX is also open source now, and you can integrate it with all kinds of stuff, imagine, for instance, doing crypto, which is, by the way, a future project I'm working on. So let's say I'm currently working on talking to crypto blockchain like Ethereum, you know, calling smart contracts, deploying smart contracts. And again, low code here would be a very big, I mean, like a major player, because lots of people do not understand what is crypto is about, and it's so convoluted. The whole idea of blockchain is so convoluted, so they don't wish to, you know, like, they are kind of taking back. They don't wish to step in. So imagine if we provide them with a low-code tool like PowerFX that is extended to do transactions on something like Ethereum, or talk to smart contracts, or deploy them. I guess that would be, I mean, like, a game changer in the future.
Thank you, Fadi. Okay. So once again, I want to thank you, Fadi, and it'd be great to actually see you at some point at an in-person event. You know, you're based in Ireland, is that correct?
Yeah, in Dublin. Yeah,
in Dublin.
The weather is not great today. So, by the way, the weather comes with a silver lining, because every time it was raining, I took the time to work on this project. So here you are. Here you go.
Fantastic, Fadi. Well,
yeah,
we really appreciate you joining us and sharing your creativity with us. I'm sure we'll be seeing you again in the near future.
Okay, and I would like to conclude by thanking all of you guys. You are guys doing a great thing to, I mean, like, to create this platform so people can share knowledge, learn from others, people knowledge. I personally learned a lot from the previous 2-day sessions, and I'm looking forward for your next year. And thanks for all of the people who are attending now. I really appreciate giving me the time. And hope I did give you something new today, something to think about, and maybe come up with new ideas. I'm available on LinkedIn. I will be sharing my LinkedIn profile, and as well, I did share my website already. If you have any questions, by all means, give me a shout. If you have new ideas, let me know. If you wish to cooperate on something, or maybe bounce ideas of me, I'm all available. So thank you, guys. Appreciate it.
Thank you, Fadi. So remember to share your contact details. I'm sure everyone would love to keep in touch with you and follow you. That's fantastic. Okay, so there you go. That was Fadi, joining us all the way from Dublin. Really